guys, so we're going to jump into 6.1 part 2 today, dealing with probability and continuous random variables. And so we're going to talk about this today. We're dealing with a standard deviation of discrete probability distribution. And in which case your standard deviation, which is labeled right here, that's your standard deviation, that's a symbol, the lowercase sigma. You're going to take the square root of the sum, right? The sigma is the sum of your x values, all your x values, right, individually, minus the mean for each one squared times the probability for that x value. Then we're going to talk about getting the variance, in which case it's just squaring the value of our standard deviation. You can just square, if you know your standard deviation, you can just square it and get your variance. And we're going to talk about probability for continuous random variables and find the area under the curve. So we'll talk about it as far as uniform and the normal curve, and which we already kind of talked about with our z-scores being our x value minus our mean divided by our standard deviation. We'll give you your z-score to go about calculating probabilities, in other words, area under the curve. Okay, and we can do this on the TI Inspire using our normal CDF, and we will show you how to do that through Google Sheets if we need to. Okay. So moving forward with this, let's look at a little problem here and work out some of these examples here. Suppose you get a new job and each day your boss, Mr. Elliott, myself, draws a slip of paper from a bag to determine your wage for the day. Let the random variable x equal daily wage, dollars per hour. So we have our dollars per hour up here. Okay. So we got everything from $1 to $25 an hour. And in a previous class, this is the probabilities we came up with dealing for $1 an hour up to $25 an hour with the slips of paper I did. It worked out pretty good. I had 2 lucky individuals in that class. I got $25 per hour, okay? So with this, let's go ahead and calculate, and then we'll interpret the expected value of x. So the expected value of this guy right here. Now that's going to be doing what we dealt with yesterday, right? We're dealing with our mean value, right? Notice I did it that way. Dealing with our mean value, we're going to take the sum of our x values times our probabilities for those. So I'm going to write these out and we'll do those calculations. So once we've wrote out all of our x values times their probability and summed them all up, the mean value with our calculator, which should come out to 7.5 with this data I have presented to you right here. So what that is telling us is if we draw many wages, the average wage is about $7.50. So again, if we draw many wages, the average wage is about $7.50. So let's think back here now. Let's go back to chapter 1 we talked about at the very beginning. And we talked about standard deviation, and that tells us that the typical distance from the mean. So let's go for it and complete a table here with this data and actually come up with a calculation for the standard deviation for the probability distribution. All right, so again, we got our probabilities right there, and we've got our mean average there, dealing with $7.50. And so we're going to fill in this table over here to actually talk about how to calculate our standard deviation by using it in this method. So with this, the formula for standard deviation that we're going to go off of, again, as we did in our big ideas, is square root of the sigma, so our sum of our x values minus our mean squared times our probability. So we're going to do that for each one of these and make this work in this table. So for these, I'm going to list out the distance from the mean. So we're taking 1 minus 7.5. So this should give you a negative 6.5. Then we're taking 5 minus 7.5, which gives you negative 2.5. Then we're taking 7 minus 7.5, so negative 0.5. And taking 10 minus 7.5, so you're getting 2.5. We're taking 15 minus 7.5, which gives you 7.5, and then 25 minus that gives you 17.5. So now we're looking at, it says the distance from the mean squared. So now we just need to square these values. You should get 42.25. You square these in the calculator. 6.25 for the negative 2.5. 0.25 for negative 0.5. Again, we get 6.25 here. And 7.5 squared is 56.25. 17 is 3. We're going to 3 a little better. 306.25. So 306.25. Alright, so once you filled that out, now it says weighted distance from the mean. So with that, you should be able to take your values you just got, you just squared, we just did this part, right? Now we need to multiply them times our probability for each value here. So if we do that, you should come up with these values right here. And once you've done all that, so we just took our values here, we took x minus our mean, squared it, and we multiplied it times p to get these values. So once we add these up for the total here, you should come out to get 38.934. Now the last step of to find our standard deviation is take the square root of that value. So the last step here is take the square root of that value. So to do that, we just take square root, and you should get 6.24. So what's that telling us? That's telling us the wages typically vary by $6.24 from the mean of $7.50. So again, typically vary by $6.24 from the mean of $7.50. So again, the wages typically vary by $6.24 from the mean of $7.50. If you're asked to interpret the standard deviation, which you will be asked that's the type of statement you need to talk about. You need to know your mean value and the actual standard deviation value. You need to include those in your statement, saying that the standard deviation value is how it varies from the mean. All right. Alright, so let's say I change my mind here, and let's say I want to assign wages that you guys will get an equal amount, or sorry, any amount between $10 and $20, and they're all equally likely. So $10 and $20 and equally likely. And I want you to draw a graph to represent the probability of this distribution. So again, you mean from $10 to $20, all equally likely, and draw a graph. Well, to do that, it's classified as uniform distribution. So we're looking at a uniform distribution. So to draw that out, again, your y and your x-axis here. And I said anywhere from $10 to $20, right? So we'll say we'll have $10 here. And we'll say we got 20 here. All right. So if we got $10 to $20 for wage, and it's all equally likely, then instead of having a normal curve, a bell curve, I should have a straight line that goes all the way across, right? Because I have the same probability. It's not as if it's a normal bell curve, right? We're not drawing a normal bell curve to go on that to make that work out, because I have the same probability. So in other words, we're going from $20 or for $10 to $20. Well, how do I figure out this height over here? Well, what you need to do is, what is the difference between the max amount you have and the least amount that we go here? Well, if you're simply take 20 minus 10, you would get 10. So for the height, it's 1/10. So we have a 1/10 height for each one of these, because therefore you'd have the same probability for each amount in here, no matter what it is. So let's think about that. Let's go ahead and let's do a probability, let's say that makes between $12 and $12.50. So say a probability that you make between $12 and $12.50. All right, so let's say $12 is somewhere, let's get a different color here. So say $12 is somewhere right in here. So that's $12. And then we'd have $12.50. I'll make it a little bit bigger than it probably needs to be, but just so it'll make it a little more visually appealing here, make it a little bit easier to see. So $12.50. All right. So in other words, the probability for that is everything in between these two lines. Right? It's everything in between here. So how do we calculate that? Well, first off, let's calculate the width. What is the width going to be here? So for our width, we're taking 1250 minus 12, which of course you guys probably saw right away is 0.5. Okay? And what's our height? Well, it's given to us, right? It's 1/10. It's our height right there. So we know the height is 1/10. So we got 1/10 and 0.5 for our width. So if we want to find the probability, then we just multiply them together and get the area under that curve. We're just trying to find the area of this rectangle in here. So if I take my length, or my height, times my width, so for the probability, you're taking your height times your width in the situation for uniform distribution. And that will give us, our height was 1/10, and our width was 0.5. And if you calculate that out, you should get 0.05 for the actual probability of making between $12 and $12.50. So again, what that's saying is there is a 5% probability of making between $12 and $12.50 based on the uniform distribution that I said I was going to pay you anywhere from $10 to $20, and you have the same chance to get any one of those values for your hourly wage. Okay? So again, for today, we're looking at the standard deviation, how to calculate that, and then we did the whole chart there of our actual values to come up with a standard deviation to work that out. Makes it pretty straightforward. Again, if we needed to calculate our variance, if it's asked for a variance value, we just need to square the standard deviation value. And then we went off of continuous random variables, in which case we talked about a uniform distribution for that, which again, it's this guy right here. Okay, we talked about this setup, in which case all the heights are there. Okay, so in this, the reason why it says 1/x here, because it did the difference between 0 and x. So of course x would be the value. So again, this is the difference between whatever two values you're looking at there. And the reason why that height is easy to calculate is because it's not like a normal curve, right? Where the slopes are changing throughout our whole normal curve over here. We're talking about this guy. There's different calculations we gotta do for that to figure these probabilities using a normal curve. And that's where that's where the z-score comes into play to actually calculate those out and do it with a normal CDF in our calculator. So, hope you learned a little bit more today. is more sense dealing with your probability and continuous random variables. And I'll see you next time.